Okay, welcome back, students. So I just did 9C from the Ed Coast B paper, and I just want to explore a little bit further and talk to you a little bit further about maybe how we would apply best problem solving before moving on. So in the looking back stage. So one thing I would do is here I filled in some of external angles. So let's just go with this one here, and I'm going to make a copy of that so I have control and I can add YouTube video. I might add this YouTube video, for example. Copy of external, so I'll take away the word copy of and I'll save and close that. Okay, now I'll find that back in my my own resources now on the top. Oops, I clicked something funny there. This one, okay. Also I'll publish it so that others can come in and look at my activity. Okay, and let's blow it up large. Okay, so I presume we've got control here of our quadrilateral. It's any quadrilateral this time, and we're looking at the green indicated external angles. So as I slide I can go really small. That's cool. That's another argument. So that as you shrink it away, all of 4 points can shrink away to nothing, and then we have the angle and a point. So that's an alternative argument to the one I used in the previous video. Nice, like it. Okay, but another thing I want to say is, imagine if we turned this into a rectangle. Okay, so just if it's a rectangle, then wouldn't it be true that the externals are 90 degrees? And that just makes it easier to do the calculation. And what we say about this situation, you can say, but hold on, you made it a rectangle, therefore it's not the general. But in that situation, with it being a rectangle, you can kind of think intuitively. It doesn't take from the fact that it doesn't destroy the generalization, if you like. I'm kind of stuck for words here. They'll come to me later. That's part of learning, by the way. You will know you want to say something, and you have to sometimes go off and research how best to say it. But it's, what's the phrase? Sorry, I'm going to keep thinking here. It's something like what is it? It's something like generally. Okay, I'm going to switch over to camera. I'm going to switch over to camera and say, and I'll just even come up with a situation. Let's say you have a squared equals 5. Okay, now you could say taking the square root would require a plus and a minus on both sides, and you could say that the plus or minus a is equal to plus or minus root 5. You could apply the square root property on both sides. But you know what, like the plus version here is to say the minus version here being equal to the plus is the same as the plus version being equal to the minus. So I'm still waiting for that expression to come to me. I might have to go to ChatGPT next. I'm going to go to ChatGPT, lads. Here we are. Now I think I mightn't be able to talk to it live because I think my microphone is tied up in this video. Let's see. Can you hear me, ChatGPT? I presume you can. So I'm looking for this expression, which is that when you do something in maths where you want to say it does not take away from the general situation.
Hey Ronan, I hear you loud and clear. If you're looking for a phrase to describe something in math that doesn't alter the general situation, you might consider does not affect the generality or preserves the generality.
No. There's a famous expression, or a well-known expression. It's written in textbooks very often, and it's used in maths parlance quite regularly.
Ah, I think I know what you mean. Are you talking about without loss of generality? It's a classic phrase used in proofs and explanations to simplify a situation.
Okay, there we have it. It is that, I think. I don't think he's used the exact right words, but even though I seem to be general, I do seem to be going away from the general to the specific, the result isn't destroyed. Okay, so without loss of generality, maybe it is without loss of generality, we can assume the left hand side is positive. When taking square root of both sides, for instance. Yeah, without loss of generality. Yeah, that's it. Yeah, it is. I know that's the expression now. Okay, this was a very long, stretched out one, but without loss of generality. I'll switch back to camera one last time. So when you're thinking about this, there are times when you can simplify the picture. So we could turn this into a square and simplify the picture. And you're going, what are the external angles? External angle 1, external angle 2, external angle 3, and I drew that the wrong way, external angle 4. And of course then the fact that they're all 90 just makes it convenient. So without loss of generality, without loss of generality, assume it's a square. But better still, without loss of generality, retract all the points to meet each other, and then you've got angle and a point. That's the other thing we saw. So this is just sort of exploratory maths. It may have been very slow and stretched out, but it's the reality of proper maths research and language acquisition. So the big one here is the phrase without loss of generality. And of course it'll start cropping up now as I get opportunities and we get opportunities to use it. As always, students, I will see you in the next one.